Hello class, we're studying solving our trig equations for the second day, and I just have a couple examples I'm going to work through with you, similar to ones that are going to be on your assignment for today. So this first one says solve the cotangent of x minus the cotangent cubed of x equals 0 on the interval 0 to 360. So this again tells us that our angle is, number one, going to be in degrees and going to be in between 0 and 360. 360 not inclusive. So this is another situation where we will be factoring out a greatest common factor. The greatest common factor here being cotangent of x. And as with any factoring problem, you set each factored portion equal to 0 and continuing to solve your smaller equations. So a lot of times we don't like to think about cotangents, we like to think about tangents. So we have the tangent of x. If you flip this side, you will also flip this side. Has to be 1 over 0 or undefined. Here, you're going to subtract the 1. And then you have the cotangent squared of x equals -1. And it's negative cotangent squared of x. So then you have the cotangent of x equals +1. And you'll flip that one as well. Because again, a lot of times it's just easier to think of things in terms of tangent. And remember, this fraction is 1 over 1. When you flip 1 over 1, you get 1. So if the tangent is going to be undefined, coming back over here, in theory, you would be on your unit circle. So when your tangent is undefined, that means your sine divided by your cosine has to be undefined. That occurs when 0 is in the bottom of the fraction, so you're looking for a place where a cosine is 0. So in this case, we have 2, where the cosine is 0, at 90 degrees and 270 degrees. Then here, the tangent squared of x equals 1. Technically, I would need to square root both sides here, so the tangent of x equals plus or minus 1. Now here, you might think that since it's a 1, it's automatically on the unit circle on a quadrant, but it's not. It's 45. This represents all the 45-degree angles since it's a positive and a negative. I always draw this picture because I like to make sure that I remember to find all my angles. So here, my angles are 45. Then in this picture, 180 less than 45, which is 135, and then a little bit past 180, so 180 plus 45, which is 225, and then almost all the way around the circle, so 45 less than 360, which is 315. And this would represent all of your solutions. Now, you always want to think and take a minute and go back. Anytime you have a tangent or a cotangent or a secant or a cosecant and you have zeros and 90s or 270s or zeros and 180s, just kind of mental math and plug things back in up here and make sure that they work. The cotangent of x minus the cotangent cubed of x has to equal 0. So for 90, cotangent would be cosine over sine, so 0 over 1, so that's 0. So both of those are going to be fine. Just always be aware that you have the potential for extraneous solutions. Now let's check this one out. Sine to the 4th of x plus sine squared of x minus 2 equals 0. Well, if this didn't jump out at you as a factoring problem, it should, after I take a second, just to write it like this. If it was x to the 4th plus x squared minus 2, that should jump out as a factoring pattern. It would be x squared and x squared, because x squared times x squared gives you x to the fourth. And the numbers that multiply to -2 but add up to +1 would be +2 and -1. That would be how you factor it. Since it's got signs in it, just replace the x's with the sine of x. So I have the sine squared of x plus 2 times the sine squared of x minus 1 equals 0. Then again, you set each factored portion equal to 0. And solve each smaller equation. So the sine squared of x equals -2. And then you have to square root both sides. And stop right here. There is no way that the sine of x is going to equal an imaginary number. So this part of the equation has no solution. You can just stop. Now let's look at the other side. Oops. I forgot to write down part of the equation. We talk about that all the time, right? Always make sure you write it down correctly. So here, add the 1 to both sides. So the sine squared of x equals 1. And then the sine of x, when you square root both sides, has to equal plus or minus 1. Don't forget your plus or minus. Then, going through and solving it, you've got this one is going to be on a quadrant because you've got a 1 and a sine together. Remember that sine is your second number in your coordinate on your unit circle. Oh, that should be a +1. So the x values, or the angles, in which the sine value is positive or -1 would occur at 90 and 270. But, again, check your interval. We are in radians right here. So, yes, it is 90 and 270, but my answers need to be in radians. So, in case you forgot, I'll go through it again. 90 times pi over 180. This converts degrees to radians. So one answer is pi over 2. And then for the other one, you have 3 pi over 2. Since we're dealing with sines, and even though we have angles in the quadrant, since we're only dealing with sines, we don't have to worry about extraneous solutions here. The next question, determine all the solutions. So keyword all. And we talked about this briefly at the end of class. But whenever we have all solutions, our answer kind of looks like an equation. Your answer will have a radian measure in it. And we're going to get a little fancy with it. But first, let's look at the equation. We'll solve it like normal. This all part only comes into play at the very end. So I have 2 times cosine squared of x minus sine of x minus 1 equals 0. So right away, you should see a little red flag. Because here, you have cosine squared and sine in the same equation. Some of the factoring problems that we've done, we've been able to factor out a trig function so that when we have equations that we solve, we are just working with one at a time. In this case, we don't really have that. We have cosine squared of x, and then we have sine squared of x. So this means that I'm going to have to do some kind of substitution in order to get my equations to have all trig functions. Conveniently, we talked about some identities. In fact, we talked about this one. Sine squared plus cosine squared is 1. Well, if I manipulate this equation, I know that the cosine squared is equal to 1 minus sine squared. And if I bring in a sine squared, instead of this cosine squared, I'm not changing the equation at all because cosine squared is equal to 1 minus sine squared. But now your equation has all signs in it, which is then going to make it easy to solve. If you didn't replace this with 1 minus sine squared, the only way you could have solved it would have been to maybe try to use a graphing calculator. So now, let's follow the rules of algebra. 2 minus 2 sine squared x minus the sine of x minus 1 equals 0. Let's combine some like terms. So I have negative 2 sine of x minus sine of x, and then 2 minus 1 is 1 when I combine those like terms together. And this is again, whoops, forgot my square there. This is again going to be a factoring problem. I don't like it when I'm factoring and my leading term is negative, so I'm going to go ahead and just divide everything in here by a negative to make it become positive, which for my brain is a little bit easier. Okay, so now looking at this, you're factoring with a leading term, not 1. And again, this is an area in which a lot of people struggle when it's x's. So if I come over here off to the side and I treat it like this, first I need factors of 2. So the numbers that multiply to 2 are 2 and 1. Numbers that multiply to 1 are 1 and 1. And I need this 1 to be a negative. And I need this to be a positive. So if I put my negative here, my positive here, and I check myself, that's x. And that's negative 2x. Well, negative 2x and x don't actually make positive 1. They make negative 1, which tells me that I maybe put my signs in the wrong spot. So if I say that this is the minus and this is the plus, then I have a negative x here and a positive 2x here, which then makes 1. So this factors the same way this does. So we're going to have, instead of 2x, it's 2 sine of x plus 1, oops, minus 1. And then sine of x instead of x minus 1 equals 0. And from here on out, this should be a pretty simple solving problem. I create my 2 smaller equations. So I add the 1 over and then divide by 2. So the sine of x is going to have to equal 1/2. Here I've got the sine of x minus 1 equals 0. So here the sine of x has to equal 1. So here you got to think about your all students take calculus. You want to know where the sign is positive. It's positive in the first and the second quadrant. So what angle has a sine value of 1/2? That's 30. So again, we're going to have to go all the way back to the beginning. Our answer is going to look like an equation, and we're going to be in radians. So first, a 30-degree angle in radians is pi over 6. So one answer is going to be all forms of pi over 6. Another answer, you start here and you rotate that way. Remember, a full rotation, or a 180 degrees, the equivalent form of that is pi. So you need pi over 6 less than pi. Or think of it as 6 pi over 6. You need pi over 6 less than 6 pi over 6. So that's 5 pi over 6. Now, again, we talked about this briefly at the end of class yesterday, so you might not remember. But you have pi over 6. You want to represent all versions of pi over 6 because the directions say determine all of the solutions. So really, all you have to do is think about the fact that every time I rotate a full circle, I'm going to be back at pi over 6. So to represent rotating a full circle, I say plus 2 pi. And then I stick the number in there. The n is representing an integer. It can be a positive or a negative integer, but basically any number I plug in for n is going to give me some version of pi over 6. Remember, the word for that is coterminal. And then the same thing here. Pi over 6 plus 2 pi n represents all of your solutions. Since we're dealing with sines and cosines, when we have sines and cosines, we don't have extraneous solutions. So we're pretty cool there. So now let's think about our second equation. We're not finished yet. When the sine is equal to 1, we're on a quadrant. So we want to know where the sine is equal to 1. That's equal to 1 at 90. That's the only place where the second number in all of these points, the y value, is 1. 90 degrees in radians is pi over 2. And again, plus 2 pi n. So that's the second part of your answer. So this answer is threefold. Here, here, and here. Okay, we have one more example, and then the rest of the time is yours to work and get caught up on your assignments. And this one's actually kind of tricky. So if you're looking here, we have cosecant minus cotangent equals 1. Now, we don't actually have any identities we can use. There are two different trig functions, and I can't really factor. I could try to write things in terms of sines and cosines, but that just makes fractions. And fractions make life more complicated, so I try to avoid it. Sometimes it's unavoidable, but in this case, it's actually a little bit avoidable. There is kind of a trick that I can do. The trick involves using a Pythagorean identity, but I got to do a little bit of work to get the Pythagorean identity in here, because there is a Pythagorean identity with cosecant and cotangent. I just divide everything by sine. So if I divide everything by sine, I get 1 plus cotangent squared equals cosecant squared. Now, if I could get a Pythagorean identity into this equation, I would actually help myself out a whole lot. So to do that, it almost seems like cheating, but the first thing I'm going to do is move the cotangent to the other side. Kind of like when you're solving and you have a bunch of radicals in the same equation, it helps to isolate one thing. I chose to isolate the cosecant. You could just as easily isolate the cotangent if you wanted. Oops, that's not squared. So, my only option now is actually to square both sides of the equation. Now, why in the world would I do that? Well, squaring both sides of the equation, yes, makes the equation more complicated, but allows us to use Pythagorean identity, because now I have squares. Pythagorean identities only work with squares. So I have cosecant squared x equals, remember this, you can't just square both numbers. This is 1 plus cotangent squared x times 1 plus cotangent squared x. And after you multiply that all out, it's 1 plus 2 cotangent squared x. Oh, I'm sorry. I wrote a square here. It's not squared yet. Plus cotangent squared x. There we go. My apologies for that. And then this is now cosecant squared. Now the magic that happens here is now I can actually get all cotangents. So if I replace cosecant squared with its corresponding Pythagorean identity at 1 plus cotangent squared x equals 1 plus 2 cotangent of x plus cotangent squared of x. So, looking at it, now I'm actually almost finished. I have all cotangents, so now I can work on isolating the cotangents. And actually, if I subtract 1 from both sides, the 1s are going to cancel. And if I subtract cotangent squared from both sides, the cotangent squareds are going to cancel. So I'm actually left with 0 equals 2 cotangent of x. So that means that the cotangent of x has to equal 0. Which means my tangent, because again, I don't like to think of things like cotangents. I like to think of things as tangents. Which means my tangent is then undefined. Which means this angle has to be on a quadrant, because that's where I get undefined tangents. So remember, when tangent is undefined, you've got like sine over cosine, and you have a 0 in the bottom of the fraction. So I'm really looking where cosine is 0, which is here and here. So I get 90, and I'm on my interval 0. We got to scroll up really far. Determine all solutions. Oops, sorry, I scrolled up too far. 0 to 2 pi. So pi over 2 and 3 pi over 2. And again, when I'm dealing with tangents, I just want to go back and make sure that this creates a true statement. So cosecant of 90 and cotangent of 90. I want to make sure that both of these end up making good solutions for me. So here, the cosecant of 90 cosecant of 90 is reciprocal of sine, so that's 1 minus 0, so that's 1, so that's cool. And then for 270, cosecant so my cosecant of 270, again, that's -1 minus 0. Well, that gives me -1, which isn't really cool because I'm going for +1. So I get no, that part is a no solution. So there's only one answer here that makes it true. Be careful. A lot of times when you end up squaring both sides of the equation, you almost always end up with an extraneous solution. Okay, work on your next assignment that's posted up for you in Canvas. And come in with questions next time I see you.